Good morning, Emily. Okay, well, we've got 8:30, so why don't we get started? Good morning, S&P.
Good morning.
Welcome to week number 13. Hope you had a restful weekend. I hope that you didn't get blown around too much last night. We had a couple of scary sirens, but I think we made it. Okay, so here we are in week number 13. We'll be talking about our last major topic, which is going to be speech perception today. Hope that you enjoyed the video on that. I think it's a fascinating topic, and we've got a couple of handouts that are going to be supporting this and developing this, so I hope that you've picked those up on the way in. Just as a reminder, we've got exam 4 coming up on Wednesday, so the next time we meet, we'll have our final section exam of the semester. And this is what we've gone over a couple of times. This information is available, as always, on the S Drive and on Blackboard, so nothing new there. The same format as always. The content is cumulative as always. The emphasis will be on the material since the last exam. People were asking about one of the papers that we had. Michael Vaughter and I had written a paper, and people wanted to know something about whether that would be on there. Yes, that is in this interval, so that is going to be on there. It's a fairly long paper, and I try not to ask lots of trick questions. So one of the things that you might study for that would be something like really know the abstract, really know the general research question, and some of the independent variables and dependent variables, and the overall findings. But I won't ask you to recall very specific details about stimuli that are not general to the, or are not sort of capturing the main ideas in the experiments. We wouldn't expect you to know all of those details. So stay with the abstract, stay with the main ideas, independent variables, dependent variables. If you could graph some of the results, that might be a good idea also. But there are lots of graphs there. You won't need to know all of them. Just understand the main ideas. Okay, so we've done that many times before, and that's available to you on the S Drive and Blackboard. Okay, a couple of other reminders. Last time we were together, we had a handout on what you'll be doing for Friday. So on Wednesday we have our exam. On Friday we'll have another student-generated discussion, and this will be entirely on a video called Here and Now. And the Here and Now video is about this 65-year-old couple that has cochlear implants when they're 65. Really very interesting. This is available to you on by loan at the Doane Library. If you'd like to go to the library, and it's on reserve. I think I've got 4 or 5 copies there, and you can listen to that at your leisure. Please go ahead, Mona. I think you've got to watch them in the library. I think so, yeah. And so what happens there is you can take them downstairs to that sound lab and then bring them right back up. Okay? It might be that if a few of you went over at one time, you could probably find a space where several of you could watch at one time if you wanted to do that. But so they won't let you take them out of the library. Okay? All right. One other note, if I can just set the stage, just because every once in a while I've had students who get anxious about what is this semester end project that we do. After we come back from the Thanksgiving break, we'll have a speaker, Dr. Lynn Robertson, who very recently retired. She'll be coming back to us. She's a Denison graduate herself, and she happens to have a daughter who has cochlear implants. And she's become extremely active in the Alexander Graham Bell Society, which is for folks who are hearing impaired. And she'll be talking to us about her life experiences with being a mom of somebody with cochlear implants. I think you'll find that to be really very interesting. And then we'll get back to this P&J paper that we've just handed out. Our 4th paper is something that you have as one of your handouts. That'll be our final paper. Then during this last week of classes, we'll be preparing for a presentation that we're going to be making. What we'd like to do is have small groups of students put together posters. And the posters are going to be presented, at least the plan for the moment is they'll be presented over in Slater Hall. We'll be there in the morning during this time interval, 8:30 to 9:20, on really our last day of class. And groups of 2 or 3 of you will be presenting a poster on something related to disability, power, and justice. And this has been a lot of fun in years gone by. What I would mention is that I do have an idea. We can do this just like we've done in recent years, or if you're up for it, I would be happy to have individual groups. Instead of making a poster presentation, we could record you and we could put you up on YouTube if you wanted to do that. I'd be happy to see if people prefer to have a PowerPoint presentation that we could record, and then we get the word out about the power and justice issues relating to disability by way of YouTube rather than by way of Slater. So I'll let you think about that. It's really the same project, and you would either present that during Slater or we'd have you do a PowerPoint presentation. It might last 7 or 8 minutes. It wouldn't have to be really long. And then we could do that on YouTube. We'll see what your groups want to do, but that would be a fun option. Now that we've got the YouTube thing going, it might be good to take advantage of that. Okay. All right. So questions about where we're going for the next several sessions? Yeah, please.
Can we find the Here and Now video online somewhere?
The Here and Now video is, to my knowledge, not available anywhere on YouTube. Okay. Yeah. I haven't found it on YouTube. I haven't found it on Netflix. In case. Yeah, right. I think it's tightly copyrighted. So I actually purchased 5 copies. I have 5 DVDs of it. So those are available that way. Yeah. Okay. Other questions? Okay, I wonder if before we get into speech perception, we might just pick up on one of the questions that we ended on the other day. A few of the folks were interested about the motion after effect, so I thought we'd do a really quick motion after effect demo. The motion after effect was a question that I think Becca and Kirsten had when we were talking about Ray Stanley's article, and he Skyped in with us the other day. So let me see if I can go out here and dial into our motion after effect. Okay, what we'll do is I'll turn down the lights and we'll have you adapt to some moving stimuli. These will be some expanding and contracting radial stimuli. If you can keep your eye right here on the blue dot, and then we'll see what kind of after effect you get. They'll put up a stationary image after you adapt to this, and I think you'll find a really interesting after effect. So you can keep your eye on the blue dot, and in just a moment, some motion after effect inducing stimuli will come on. Okay, keep your eye on the blue dot. You can blink if you want, but it works best if you can really jazz up your system by staying right on that center blue dot. Okay, hopefully. Okay, that is a stationary pattern that you're looking at right now. It might not seem that way. Okay. All right, can somebody describe what they're getting as an after effect? Okay, thanks, Molly.
To me, it looks like it was just like kind of waving.
Okay, yeah, kind of waving back and forth, right? In certain areas, it might have been expanding, it might have been contracting in other areas, okay? So what we can say then, we'll just draw this on the board one more time. We've done many after effects. Sorry for the bright lights that are about to come on. We've done many different after effects, and they all have the same kind of general pattern. We just relabel the axes, but the theme is always the same, and that is that we've got a plot of neural activity, or if we like, we can call it sensitivity. I'll leave it as S for sensitivity. You can think of this as the number of action potentials that we might be getting. And here we'll have radial motion. In fact, I'll call it radial motion tuning. And the idea is that we have neurons that are tuned to certain orientations. We have neurons that are tuned to certain spatial frequencies, all the FAPO properties, right? We've had that before. We also have motion-sensitive neurons. Some neurons will fire a lot of action potentials when rightward motion is presented, others when there's leftward motion presented. Others will fire a lot to expansion, radial expansion, when something is, you drop a rock in a pond and those waves are going outward, that's expansion. If you play that movie backwards, that's contraction, okay? So we might have some ensemble of neurons that's tuned to, I'll call it contraction, expansion. We'll start out with that one. You have other neurons that are tuned to contraction. So these are radially sensitive, right? They pick up radial motion. There are different kinds of motion. There's linear motion, there's radial motion, there's rotational motion. Cell is an area MST, the medial superior temporal lobe, are tuned in this way. They have tuning to these radial directions of motion. And as always, we typically can take a stationary stimulus, maybe right here. It's neither expanding nor contracting. Okay? Neither expanding nor contracting. And these two different kinds of mechanisms are going to be in equilibrium before we get to any kind of adaptation. And then we have you look at that thing for 30 seconds, and portions of it are expanding, portions of it are contracting, and so forth. And we might get something like this, for example. We might get the sensitivity of this contraction, I'll just pick on that one for the moment, is brought way down. And so the tuning now after adaptation is much, much lower. And now what happens is when you look at the same stationary stimulus, you're getting a stronger response from the expansion neurons than you are from the contraction neurons. And when that happens, you see some expansion in something that is actually physically stationary. Yeah, please.
In this situation, this example, wouldn't both of them be less sensitive or lower in sensitivity? Yeah,
so what happens is as you're holding fixation, we do have all over the screen some local examples of expansion, some local examples of contraction. And what we can say is that at any one region of space, we're getting either or, but not both. Okay, so at any one region of space, for example, maybe we happen to have contraction going on, and that tends to lower the sensitivity of this contraction-tuned ensemble of neurons. In some other region of space, it might be that expansion is the one that's coming down.
So this represents a small sample.
Yeah, right. That's right.
Mm-hmm. Okay.
Right, okay. And so this works really the same way as always. We have some reduction in sensitivity after adaptation, and that throws our system out of balance, and that imbalance, at least momentarily, creates the illusion of some kind of motion after effect in this case. Okay. Who remembers seeing patterns like that before? We've done that for color, right? And you can do that for size or whatever the feature happens to be. You can do that for temperature too, right? If you're talking about having your hand in hot water or cold water, right, or room temperature water, right? So it's a general feature of our nervous system. And true across many of our senses, true across many different animals. This isn't just specific to humans. Okay? All right, so hopefully that helps with the motion after effect. And there are auditory motion after effects. You can hear sounds going off to one side, off to your right. Okay, and then you play a stationary sound and it seems like it's going off to the left. All right, why don't we go ahead and begin some conversation on our speech perception. This is what you read for today, and this is what you saw in the video for today. Lots of interesting topics here. Sorry that we have only one day for it, but we'll make the most of our one day that we have. And I think it would be fun to begin with a question that we started on in the PowerPoint presentation, and also in the video. What distinguishes human language from the way other animals communicate? Anybody want to help us out with some ideas about that? Thank you, Jenny. Yeah.
Well, one of the things I was thinking is something like we have like explicitly taught rules, kind of like grammar and syntax, and yeah, I think it's the main part of that is like explicitly taught. It's not just imitation. We have explicit ways of teaching.
Okay. Okay. So we're very precise about how we teach. Okay. So the environment in which the children are learning is very different than maybe for other animals. Why don't we go with June and Becca and Harshita?
Well, human language is kind of distinct from animal languages or animal communication because it's mainly symbolic.
Okay.
Wherein when a word or a sound symbolizes something that's outside of the environment, whereas in animal languages, in what we believe to be animal languages, there are patterns that indicate that something may be coming, but it's not necessarily symbolic.
Okay.
You don't necessarily associate a meaning to a specific pattern of sounds. Whereas for humans, if you hear a specific pattern of sound, like I say dolphin, you know what that means. Whereas for other animals, it might not necessarily.
Okay, so there might be a level of symbolism that we have that other animals don't have, a representational level of complexity. So, and we can talk about symbols being analogical or representative in other ways, right? Was there other ideas?
I was just going to add that it's just that it's much more complex, and there's a wider array of meanings and a wider array of symbols that we can assign meaning to. Okay, so it might be the case that it's quantitatively different, and that maybe there are symbols arguably in other animal communication, but we have many more of them and many more subtleties. Why don't we go with Harshita and then also with Yuan? I was actually going to do it the other way.
I had a neuroscience professor back home who said that the only difference between human language and animal language is that we can't understand animal language.
Oh, that we can't understand animal language. Okay, so it might be as complex as ours, but we're just missing it. We're just missing it. It's an interesting hypothesis, right?
You try to code it and everything, but if you don't understand what they're saying,
okay.
how can you be sure you're right?
This is an important point. We should come back to this because we're completely misunderstanding what the non-human animals are doing, and there might be tremendous complexity there that we're just not privy to. And we think that we've got all the complexity, we've got all the symbolism, we've got all the subtlety, and they don't. We'll see if we can investigate that. Yuwen has some ideas also.
I was just going to say, human language have regional differences.
Okay.
We're from different areas, like representation for the world, but animals seems, the language seems universal, like there's no regional difference.
Okay, so we have regional accents. We have different languages. Humans have different languages in different regions of the world. Even within a country, for example, in the U.S., we have tremendous regional accents. If we have time, we'll be talking about accents later on. And I hope to take a look at a quick news story where they have some evidence that dolphins have regional accents. Depending on which side of the Irish Sea you're on, you either have an Irish accent or you have a Welsh accent, according to one study for the dolphins. Owen had something else. And then we'll come back to Jenny.
That there was a similar finding among whales,
Yeah.
that like there will be a whale that like starts a new song, and that song will catch on amongst the whales that are around it, and they've been able to see like the spread of popularity of certain whale songs.
Okay. Okay. All right, so whales have their top 40 also. Okay. Some of them are really catchy, some of them are less so. Jenny had another comment.
It kind of goes along with, I think, the symbolism aspect, but like humans kind of use language or speech to kind of express emotions.
Okay.
Like happiness and sadness, and we can say like animals express those emotions for sure, but they do it more with body language.
Ah, okay.
From what we've been able to tell, then we use the speech.
Okay, we use speech, right? Yeah. Although I might imagine that you might say ASL, right? American Sign Language would be a form of, arguably, a body language, right? But it's interesting that the animals might use a puffed up tail or rearing behavior to communicate their fear or their intent to harm. Yeah, please go ahead.
Actually, I read an article about, very sad, about this whale who's singing a different song from anybody else,
Okay.
and nobody can hear it, so the poor thing is all alone.
Ah, okay.
Which is actually a difference from human language, because even if someone was saying something different, you could infer.
Okay. Very good. Briella had something.
I was thinking of what we learned about like an intro is like no Chimsky.
Noam Chomsky. Okay, good. If you can bring that back for us. But what do you remember about Noam Chomsky?
That this guy tried to say that he could teach a chimp the English language, and that he did, and the chimp could like understand words, but he couldn't understand the grammar and the syntax and everything.
Okay.
So it doesn't necessarily mean that animals don't have that, but it could suggest that if you couldn't understand it, that animal language probably doesn't have like grammar, syntax.
Yeah, that appears to be what most linguists agree on, and that is that whatever ideas we might have here, and however good they might be, a really distinguishing factor is this bit about syntax. Right? And syntax is a grammatical structure, and you might think of syntax as designation. In syntax, we designate, for example, who the subject is in a sentence and what the object is in a sentence. Right? And so we know what's playing what role, and it's really hard, despite lots and lots of years of trying, to demonstrate that animals have syntax in whatever communication they might have. So syntax is designation. This is part of grammar. Thank you for reminding us, Briella, about Noam Chomsky. Right. So Noam Chomsky is who's heard of Noam Chomsky before? He's the actual linguist, and he's still at MIT and still going strong, and was the mentor to Steven Pinker, who some of you might know. So it was actually B.F. Skinner who wanted to show that we can get chimpanzees to acquire a language, and Skinner, who's really good at getting animals to acquire all kinds of behaviors, was never able to do it. He was the one who tried to get Noam Chomsky to show syntax, and he couldn't do it. Yeah, please.
I was also going to add to that I believe that the other thing that they demonstrated in these experiments is that a chimp, due to its reduced, like its smaller size of the frontal lobe, its capacity to, its word capacity when it was learning the words was a very, very small fraction of the overall human language.
Yeah, right. So you can get chimpanzees and other kinds of great apes to learn symbols, and sometimes they even develop their new symbols. One of the famous examples is that a chimp had learned the word for water and had learned the word for bird, and then had seen a seagull and created water bird. So they do have symbolism, they can synthesize, but a much smaller vocabulary, sometimes on the order of maybe several hundred words, something like that, whereas you have probably tens of thousands of words, maybe more than 100,000 words, and young children have on the order of several thousand very easily. Yeah, please.
Just to kind of critique that, the fact that chimps have a limited, only have a limited amount of human vocabulary that they could learn, may stem from the fact that they're evolutionarily not equipped to learn human language.
Okay.
Whereas, for us, we learn human language partly because of our evolution, and our bodies have basically changed to be able to express language, human language.
Mm-hmm.
We have the vocal cords, we have the associated vocal cords to reproduce the language,
Okay.
and the equipment upstairs to actually understand it. Whereas chimps were never really evolved to speak human language, so their mental faculties, along with their physical capabilities, would be vastly more limited.
Okay, yeah. So they have very different, at least over the last maybe 7 million years, we have very distinct evolutionary histories, right? And it is an interesting idea to use about whether the limitations in chimp language or chimps' attempt to emulate human language is related to their vocal apparatus, or if it's something else, maybe more of a neurological limit. And so the idea is that if you use sign, then a child who's learning sign will have, at least in principle, as rich a vocabulary as spoken language children would have. But the chimps never really get past the couple hundred words, even if they're using sign. And it's not a physical limitation that way. So it's probably more of it might be frontal lobe, as Becca is saying, but yeah, interestingly, over the last 7 million years, we have had distinct evolutionary histories. The one bit that I hope you'll always remember about this is the very easy distinction between this, man bites dog, versus dog bites man. Okay, so we have the same 3 words in these sentences, and what's going on here is really a syntactic manipulation. We have the idea that in one case the man is the subject and the dog is the object, and then just by flipping this around we have the reverse. We have now what was subject is now object, and this is something that came up in the Nim-Chimpsky experiments, right? The idea that chimps seem to be relatively insensitive to this. Chimps can very easily begin to sign to indicate that there's a man in the picture, there's a dog in the picture, and there's biting going on. They have no trouble signing that. But they seem to be, as far as we can tell, and people have coded and recoded, they can't tell that chimps can reliably make this distinction, and young children can do it very, very easily. Okay? There's a gene called FOXP2 that seems to be, at least, I'll put that up here, FOXP2 seems to be associated with some of these language-related impairments that speak to issues of syntax. There are a few humans that have an older version of FOXP2, one that's more similar to the chimpanzee version, and whenever that happens, there are tremendous language impairments in those folks. Although there is still some limited ability of syntax in these folks. The FOXP2 wouldn't be the one-size-fits-all, one gene, one ailment kind of solution, but nevertheless, that is probably the distinguishing factor between us and chimps, syntax. Us and really all other animals. Okay, so enough about that. We've talked about how we're somewhat unique. Why don't we go on and see if we can talk a little bit about, on slide 7, one other question that I posed here, and that was trying to get us back to some of the physiology inside of the inner ear. We're talking about which end of the ordinate is apical and which is basal, so we can think about our basilar membrane. I wonder if somebody can line us up in some way with the basilar membrane and this y-axis. Becca's got something.
The apical would be on the lower side, so on the bottom of the ordinate.
Okay.
And the basal would be up here, yeah.
Okay, right. So the base is going to be up here, and the base is where the basilar membrane starts. So you might remember that we had the door closed the other day, and we had the oval window, and the stapes is banging on that. Okay, that's going to be the basal end, right? And that's going to mean that we have relatively high frequencies encoded there. And then as we go to lower and lower frequencies, we're moving our way on down toward the apex. Okay. All right, so we're just trying to connect to the spectrogram. Some people have seen spectrograms before, some people have not. We have this plot over time, and we have the frequencies here. And it's not coming across very obviously in this picture, but you can have different shades of gray that correspond to how much energy you've got. Okay. All right, so that gives us one notion about that. I wonder, oh yes, please.
Could you do spectrograms with sentences also?
With sentences? Yeah, absolutely. So we do this in the, I wonder if we'll go back here. Let's see where we might have them. Okay, right. So we do have some sentences. Here's the word spike, but I think I talked about somebody giving somebody else flowers in the video, right? And we talked about how you can see those differences inside of a spectrogram, right? You can emphasize different portions of the word, and then also you could have sweeps upward, right? That might suggest that you're asking a question. I don't remember what the names were. Somebody was buying Mary flowers. Who? Joe was buying Mary flowers, or somebody. Yeah, somebody was buying the flowers. So, Joe bought Mary flowers. What does that imply, by the way, when I say it that way? Joe bought Mary flowers?
As opposed to getting them for free?
Yeah, so Joe's really cheap, right? So we changed it's really interesting where we put the chirp in our spectrum, right? If Joe bought Mary flowers, implies that Joe is cheap, right? Joe bought Mary flowers implies what?
The person.
Okay. Okay, right. So wrong woman, right? Okay, maybe he's buying flowers for somebody else's love. Okay, and so that doesn't sound quite right. Okay, so but all of that information is conveyed just by the little frequency manipulations that we get, and emphasis also in acoustic energy, right? So so this is going on all the time. As I'm speaking, as you're asking questions, we can create a spectrogram for all of these and pick up all kinds of intonations. Okay. I wonder if somebody can help us out with some of the issues related to vowels and consonants. Can somebody help us to understand how those are distinct from each other? Inside of a spectrogram, how are vowels and consonants distinct? Kirsten's got something.
Well, just that, it's for, sorry.
Does this help, having this one up here?
I'm okay. So the formants are the angled areas where there's the emphasis that happens over time of the the T and the do the parts of the consonant.
Okay. Okay.
And just kind of in sound, it's either on the first arrow it's low high, or in the second one it's high low in terms of pitch, you could say.
Okay.
I would do
Okay. All right. So a couple of ideas going on here. First, there's this notion that we have a many-to-one mapping, right? We get a pretty good D consonant here, a pretty good D consonant here, and yet normally what goes on is when you look at a spectrogram, and this is simplified just a little bit, these frequency sweeps, which we call formant transitions, carry information about consonants. Okay. So these longer bits of information that we get, they're longer in duration. They also tend to be more energetic. Those carry information about vowels, but it's this transitional information that's just sweeping in, and almost like the chirps that we talked about the other day when we were doing the echolocation in VATS. Those chirps are really something that we would call here formant transitions, and they carry important information about consonants. Yes, please.
So are the formant transitions just the...
Just the angled bits, right. And then the ones that are constant across time are the formants themselves. Okay, so formants are these long bands of energy that are extended in time, and then the sweeps that we get are the transitions into those formants. Okay, so we're transitioning into one, and sometimes there are many different frequencies going on. Here's an upward sweep and a downward sweep going on simultaneously, but at different regions of the frequency spectrum. And then here they are, in both cases, they're sweeping upward. Okay, is how those might be going. Yeah, please go ahead.
So you mentioned in the video how these could be thought of as metamers.
Yeah, right.
But I'm curious, if you have the formant transitions without the extended formants,
right.
do you still have a
D
perception of the D for both of the.
Yeah, I'm not sure if that's been done. It's a great question. So again, the question is if you can now just pull this out digitally and you pull that out and you leave the frequency sweeps, right, the form and transitions, would you get perceptually identical D sounds in those two cases? My guess is that you would. I don't know for sure that it's been done that way, but my guess is that you would. And to the extent that you do, then we do have metamers, right? These are physically different and they're actually quite different from each other, but they would be perceptually indistinguishable. Yeah, please go ahead.
I'm just sort of having trouble grasping like how this would be a metamer.
Good. Okay. How would this be a metamer? Good. So let's see if we can do it this way. And this is really getting back to Owen's question. So we are pretty confident that this is a D sound and that's a do sound. Okay. And we're getting D's in both of them. Okay. Owen's question is: suppose we could go into something like Audacity or GarageBand, one of these software packages that allows you to manipulate this. And we could take our little dial and have it go through this far, and then right about here we stop the projection, or we stop the player, and we just cut that thing out, okay? And so now we just have the first introduction of this sound, and the same thing over here. We cut out the formants, but we leave the formant transitions. Now, hopefully you can see that we have widely spread formant transitions in stimulus A, and we have more narrowly spaced formant transitions in stimulus B. Does that work for us? So this is physically different from that. Okay? So now we have physically different stimuli, and Owen's question is, if you threw this stuff away, would this still sound like a D and that like a D, and could you make the discrimination? And if you can't, then they're perceptually indistinguishable, even though they're physically different, and that would make them metamers.
Okay.
Okay? Under that condition. Right now they are not metameric because when we leave the full formant in there, we can clearly hear D versus do. So those.
It's just the transitions.
That's right. So, and the point about that is that both of those start out with a D. So you might say, hey, what does a D look like in frequency space? And prior to this lecture, you might have thought, well, a D just has one signature. But here we can see Ds have wildly different signatures. Okay? They have wildly different, so they're physically very different from each other, but they all sound like D. And this was our idea of a many-to-one mapping. Right? So here's one particular signature in frequency space. Here's a very different signature, and yet both of those different stimuli map onto our psychological experience of the D sound. And we are psychologists at the end of the day. Okay? Let's go with Harshida and then with Kirsten.
So basically these two things together form the sound do.
Yeah, actually this whole bit is the do. And this whole bit is the D.
So where do metamers come in? Not for the whole bit, right? Just
right. They're metameric in the sense that we're talking about the psychological experience of the D sound. Okay? So this and this share a D, right? Okay? And yet you might have guessed that they should have had the same start, and then they could have been different in the vowel sounds, right, in the formants. Okay? Go ahead, Kirsten.
I was just going to ask like the distance between like both formants for D and do, like besides the amount of frequency it has, like is there any other effect other than or difference other than seeing it on the graph?
Is there any other effect other than seeing it on a graph? I'm not sure I'm following.
Physically seeing a difference between like the distances. Is there any other difference other than like the frequency amount between the two, or like does it mean anything else, or just like a change in frequency?
Yeah, well, they are very different. So here we have we have energy at 2400, and I'll call it 500. Here's 500 and 1200. So they're different in where they're centered. Okay, they're different in whether they're sloping upward or downward. But those differences enough. Those differences apparently are not enough to give us a different psychological experience. So I don't think it means anything more than that. It just happens to be that we have this many-to-one mapping. Okay? Yeah, go ahead, Brielle.
I'm still confused.
Yeah, okay.
Okay, so if you, just the starting point, I don't understand how they would sound the same because they're so different.
Okay, you're right. You don't understand how they would sound the same because they're so different. Let's take a look at Emily's shirt. What wavelength? Let's take a look at that. What is that? Not 590. What color is that subjectively? Yellow. What color is Emily subjectively? Yellow. I don't. Does that help? Okay. So there's who's now making that connection? Is that working for us? Very physically different stimuli, right? But they are mapping in our brains onto the same kinds of experiences. Okay. Right? So it's surprising, right? It is surprising. Yeah, please.
And then when we're looking at same consonant sound, different vowel, we look at same vowel sound and a different consonant, do we find these very different physical stimuli?
Yeah.
Or like if like between like D and T, is it the different formant transition, but the formant is relatively close?
Yeah, so it's interesting. You might be able to find for different vowels, for example, there could at least in principle be a many-to-one mapping also for different vowel sounds. It wouldn't have to be that this is true only for consonants, right? This whole idea of having vowels and consonants is somewhat arbitrary, somewhat constructed, and we can just look at for typical English speakers or for anything that a typical English listener can understand. What are the different spectra? So you could have a many-to-one mapping in the vowel space as well. Right, so the other example that I think you're getting to, we might take a sound, something like, let's see if I can put one together. Maybe the name Pete and the name, the word sheet. They both end in eat, but they have different consonants. So that's almost the converse of this case, right? Where they have different. Here they have the same starting and different endings. In Pete and sheet, they have constant endings but different starts, right? Now we can look to see if that E sound might be different in those two cases. Maybe we have another case of metamers there. Please go ahead, Becca.
So was this graph constructed based on like a computer generation of the D and do sounds, or was it constructed based on a recording of someone saying D and do, or were those different?
Right.
Based on which one you did.
Right. So the idea would be that no two of us would have exactly the same pronunciation of di and do, right? So my voice might be lower or higher than some other voices and so forth. So this would be the general pattern that you would find.
Okay.
Yeah, right. And
they wouldn't differ necessarily, like.
It's a good point, right?
Individual differences aside, they would.
Good. So if I can use that to transition, and we can come back to this if we need to, but there are some individual differences that we pick up here, right? Okay, so here's children and here's adult men. Right. Okay. So we can see that if we get to, for example, the E sound. Well, maybe somebody can walk us through this. Anybody want to help us with what we did in this bit on the video? It gets to Becca's question about individual differences in speech production. Okay, Elise has something.
It talks about how like men and children, or like just anybody, speaks with a different frequency, but they have the same general pattern.
Okay.
So the formants of children for, I think we use B, is like a big step and a little step.
Okay.
The same as for men.
Okay, right.
Big step.
Here's big step, little step, right? Okay, and then big step, little step, right?
We're more adept to detecting pattern than we are. Then we have to we don't have to have distinct frequency detection. It's just a pattern.
Yeah, it's the pattern, right? And one other idea about that, as Elise is giving us this information, I'm making eye contact with Elise as she's speaking, and now I'm on this side of the room, and somehow Elise's face is occupying a smaller portion on my retina than it would be when I'm over here. Now I'm physically closer to Elise, and somehow she still looks like Elise. I can be anywhere in the room, and she looks like her, and you look like you, okay? And yet there are these very wide frequency changes. So now Jenny's face is moving into lower spatial frequencies, and now it's moving into higher spatial frequencies, and yet she's still Jenny, right? Okay. On my retina, there's a pattern of Jenniness, if I can call it that, okay, right? Or a pattern of Eliseness that's going to be on my retina that's almost scale invariant. And so what's cool about this is we can say that maybe it's a big step, little step, and we could be more precise about that. I mean, we could say it's, that step is 1/3 the size of that. I might be wrong about that. But then if we had roughly that same pattern over here for children, and it looks like it's not exactly the same ratio, but it might be close enough, then that's the pattern independent of what frequency it's at a given moment. Who's following that? Right. At least that's a clue about how our brains might be able to do this remarkable task of pulling out speech from people you've never heard before, right? And they might have a different accent. They might have a regional accent that you're not familiar with. You've never heard their frequency, and yet they start speaking and you have no trouble. All right, that's rather remarkable that we can do this. Some kind of pattern analysis that probably brings us back into the Fourier domain. Fourier, again, just meaning frequencies, right? And some kind of frequency analyzers. We know that we have frequencies spread out across our basilar membrane. We know that we have different frequency tuning across A1, the primary auditory cortex. We know we have different frequency tuning in our visual cortex now for spatial frequencies rather than temporal frequencies. So this frequency tuning might be a general pattern analysis that can be used regardless of what particular mode we're in, hearing or vision. A couple of hands are up. Why don't we go with June and then with Becca?
Sorry, but you kind of is kind of similar to, at least in tune with like, this just kind of reminds me of like Gestalt theory.
Okay.
For some reason, wherein it's not individual tones.
That's an excellent
that
observation.
Make an important, like if it's like my closest comparison is with like a musical piece. Even if you change like the octave or like the pitch of it, so long as the melody remains the same, you basically get the same perceptual meaning of the song itself.
Sure. Right.
Would this be similar to like in the voices, wherein if a child speaks it, it's in a higher pitch, but it's still perceptually, you still perceive it to have the same meaning as when a grown man speaks it with a much lower tone of voice.
Sure, right. Yeah, that's a very good analogy. So we can think of this as being the melody as carried by the tuba, and here's the melody as carried by the flute. We still recognize it as the same melody. Right? And you can do the same thing with a chord that you might play on a piano. You're playing multiple tones at one time. You might be able to tell major chords versus minor chords. We can think of this as, if you will, a major chord to be metaphoric, and here again is a major chord as it's played higher on the keyboard. Yeah, please.
And like how making a phase shift made it hard for us to recognize faces, is there like an analogous thing that you can do to a sound that will make it us unable to perceive what's being said?
Yeah. So what could we do to sound? Well, certainly this much is true. If you play the sound backwards, okay, but maybe that's too trivial. I'm thinking that the phases are probably pretty much synchronized. So right now, as I'm speaking with Owen, I'm a little bit off to his right. I'm not dead center in front of him. So I must be stimulating his right ear a little bit earlier than his left ear, just the nature of the way the sound is traveling. But as I'm saying the word but, okay, I've got this plosive consonant that's coming out of my lips. All of those frequencies, I would guess, start emerging at the same time. Right? There might be varied frequencies, but they probably start at the same time. So if we start phase shifting components of them, I'm not sure if you still probably hear it as the same letter, but maybe you'd be not so good at localizing it. Might be one possibility. Yeah, right. I think there have been other hands. Becca's got some. Yeah.
So going back to your example with the faces.
Yeah.
So just as like the perception of Jenny's face is scale invariant, this would be the perception of speech would be frequency invariant.
That's right. That's right. Okay. Yeah. At least it's center frequency. Kids will have a higher center frequency, right? Okay. Go ahead, Elise.
Would different pronunciation of a word change the frequency, like potato versus potato?
Yeah. Really good. Really good.
They might not be able to comprehend one or the other.
Yeah, and thank you for pointing that out. So when we do get to the regional accents, that almost always the regional accents differ in their vowels, not in their consonants. And the vowels are going to be signified by these formants, not the formant transition. So these are almost always, in this particular graph, these are almost always horizontal slices, these longer extended vowel sounds, right, in time. And so that's usually what makes regional accents true, and how we have potato-potato differences. And I hope we can spend a few moments on accents. I think it's really fun, because I work with lots of folks who are from all over the world, and they really struggle. We all struggle with different kinds of regional variations. Go ahead, Molly.
I just actually have a little anecdote about that. I have I think he's 5 now, little cousin, and he's from Britain, so he has a British accent, but his mom is Australian, and he's very used to the Australian English accent.
Okay.
And he was visiting me this summer, and I said adult, and he had no idea what I was talking about. He literally was like, "Daddy, what's adult?"
Yeah.
Like said it with my accent, because he had absolutely no idea.
Is it adult? Is that what?
And then I said, I mean, adult? And he's like, "Oh, okay, yeah, mommy." I was like, yeah.
Okay.
He just had no idea what I meant when I said adult.
Now, what's interesting about adult versus adult, I'd have to listen to my own voice saying that, but there it's almost more a matter of acoustic energy, right? We either emphasize the verb, but I think I'm saying the same frequencies. At least to my ear, I hear them that way, but my ear is filled with metamers, as your ear is also. So that's kind of interesting. Please go ahead.
One question about like that mention of metamers.
Yeah.
Wouldn't it be different? Wouldn't the experience of different people, like someone who's like bilingual or trilingual, wouldn't he have a very distinctly different experience as someone who just like knows English? Because in other languages, like other languages sometimes put a greater emphasis on making distinctions in tones, whereas the ah sound would mean something very different if you said a.
Yeah. Okay.
Like the meaning would be different. So if like assuming the example you said caught and caught,
Yeah,
the
right.
difference between the Californian accents. For someone who's like very in tune to both language, to like two different, assume that Californian is a different language. For someone who's in tune with both sides, wouldn't that necessarily no longer be a metameric like experience where like you're so in tune with like hearing the difference between tone that it's no longer something that's perceptually indistinguishable?
Sure. So there will be individual differences in metamers, for example. So there are lots of, and they do this all the time with kids. We all do this in Intro to Psych. We understand that there are sounds that little kids can discriminate, and then when they become an expert in their language, they all of a sudden can't make that discrimination. This might be a phonemic difference in a language that is not theirs. Initially, they can pick up that difference. Later on, they lose that capacity. So you're right that there's going to be lots of differences, individual differences in what is metamer and what is not metamer. Please go ahead, Harshita.
Speaking of bilingual and trilingual people, sometimes things transfer over from other languages.
Okay.
Because my first 2 semesters here, whenever I was talking normally, people thought I was singing.
They thought you were singing. Okay. Okay.
I have no idea. I never thought of Hindi as a sing-song language,
but they hear it that way.
It sounds like I'm singing. Like very rhythmic.
Yeah. Yeah. Lots of great. Yeah, Emily's got something.
You mentioned, I think you pointed to the formants, or maybe both the formants and transitions, and said that we have high energy. Is that just opposed to no sound at all, or what's?
Yeah, so thank you for that point, and this is one of the points I did want to make. If I can go back to here just for a moment. So these are the formant transitions, those are the chirps, and these are the formants. First, who's okay with, is that working for, hopefully they're really clearly labeled here, you know, what the formant is. And so what I meant by this is if you were to look at the actual spectrogram, this area would be darker typically than that area would, which would indicate that you have greater amplitude. Remember FAPO? There's the A in FAPO. We typically have more energy or amplitude here in the formants than we do in the formant transition. If I can pick up on that just to complete the thought, we also have briefer periods of time for the formant transitions. Those tend to be very transient. They're on just for a bit, unless you deliberately do something like win and you hang on to it. But in everyday language, we don't typically do that. So usually the consonants go flying by, the vowels are a little bit longer, and what's really a shame about that is the consonants also tend, generally speaking, to have not only less energy and are they briefer, but they also tend to be higher in frequency. Overall, the average consonant sounds are placed higher in frequency than are their corresponding, or any of the vowel sounds. And the problem with that, interestingly, is as you get older, you lose sensitivity to the higher frequencies. So we did that earlier this semester. We saw that you can hear things that I can't hear. So when you're way up here, older folks tend to lose some sensitivity to higher frequencies, and when they're doing that, more frequently they're losing sensitivities to consonants more so than to vowels. Okay? First, who's following that much? So there's almost a deficit in the capacity to pull out consonants, and what's really interesting about that is linguists do all kinds of studies where they take a passage, like maybe something from our book, and they remove the vowels, and they have you read it when there's no vowel in the written language. And then they have it the same copy, and now they remove all the consonants. And you can almost always make out what's going on in the paragraph if you have the consonants to work with. Okay? So the idea is that more of the information in language is actually carried by consonants than by vowels. And yet it's the consonants that are high in frequency, and they're going by really, really quickly, and they're low in energy. And so as we're aging, and we're losing sensitivity to that, we have a lot of trouble with language because we're just missing the consonants. And so a lot of folks will report that being in conversation is not as much fun when they're in their later years. They're not getting the same amount of information, they're lost, and everybody else is laughing at the joke and they haven't quite picked it up yet. And it's really because they haven't picked up the consonants. It's not that they're mentally lacking, right? If it were loud enough, they would get it, right? And so sometimes they begin to isolate themselves because social interactions get to be a little bit awkward because they're not picking up the consonants, which are high in frequency, very low in intensity, and very brief in time. A fascinating connection between a small physiological change and a big social consequence. Please go ahead, Archana.
Why exactly are the formants so band-like, thick, instead of is it like they're not purely tonal? They're not pure tonal?
Why are the four ends so thick? And
Yeah, I mean,
Right.
why is it a bend instead of just a single line?
Yeah. It would be that would have to be a pure tone. Right? We'd need almost something like a violin to get an absolute pure tone,
So
right?
these aren't, what we speak are not pure tones.
They're not perfectly pure tones, right? But they're pretty well centered, right, along a particular frequency band, right? A couple of other hands have gone up, I think. Well,
Wait, can you explain to me why there are two again?
why there are two here?
Yeah.
I can't explain to you. I can tell you that there are two. I can't tell you why there would have to be two. It's just if you make the recording, this is what you find. Okay, right?
Okay, because it was just like, it can kind of confuse me at first when I saw the video. I thought these are two different ways of saying D. Like one is higher tone, another is lower tone.
Okay, right.
That's what I thought because there were two.
Right. Yeah, actually, there would be more than that, but here they've simplified it to just show you that a lot of the energy is being carried by these two frequencies, and over here for do these two frequencies. But why it is that way, who knows? It's the way our vocal cords are flapping. So when I go like this, we get a broad spectrum of sounds, and there might be particular frequencies that are not there. Why those aren't there probably has to do with just the physical construction of that table. Okay, one more question, and then we'll have to call it. Yeah.
Just kind of touching on the the phoneme rate.
Yeah.
Would you happen to know if there's been a study that's been done looking at the phonemic sensitivity of people who speak a language that does have temporal differences as opposed to like English? Because I know
Yeah.
like Japanese, it actually has like,
It means something if you separate them?
yeah,
Okay.
like you have like half notes and rests
Yeah.
when you're speaking.
Right.
So you would have like wakata, where you like take a break, and that would mean something different than just like wakata.
Ah, okay, yeah, right. No, I'm not aware of that, but that's probably just my ignorance. Okay, really good conversation. Look forward to Wednesday's exam. Can't wait for that. Hope you're psyched up just like I am. And looking forward also to seeing some of you Tuesday for a quiz. We have now a quiz on factorial designs on Tuesday for those of you who are in the research component. See you there, and please also, as your schedules allow, make your way over to the library and start watching the video. Hope you'll enjoy the Here and Now video.
Can we check them out?
You have to watch them there.
Would you be in your office anytime after 1:30?
I have a couple of, you can sign yourself up. I think I've got some openings this afternoon. Do you want to sign yourself into a time?
I have like 3 questions.
Okay, okay. If you sign yourself in, then I'll make sure I'm there. Okay, all right? On the sign up, yeah, right. It'll say first years, but you can sign yourself in. Okay? All right, all right.
Why not? Also in the formants and that,
Yeah.
which one is the vowel and which one is the consonant?
So consonant first, vowel second, right? Okay.
Yeah.
All right.
So excited.
Thanks for Nim Chimsky, Briella. That was, yeah, I was hoping somebody would come back to that. Hey, can we chat?
Yeah.
Yeah, I don't know if you got my response to say that, yes, we can chat now if that works for you. Just got to clean this up for Dr. Kennedy. Well, I'm excited that we'll have the opportunity maybe to do an independent study. I think that might be really fun if your schedule allows, and maybe you've got an idea for a project.